Hello student, good morning. I am Junior College teacher, SGM College Karad. Last time we have seen about the applications or uses of potentiometer. Some applications of potentiometer you have studied already in the previous lecture. Among them, first application to compare EMFs of given two cells, that is to calculate the value of E1 divided by E2 by sum and difference method. Second, to determine the internal resistance of given cell with the help of potentiometer. Also, we have seen some practical applications of potentiometer such as voltage divider, auto control, and potentiometer as a motion sensor. Up to this we have studied in last lecture. In this lecture we will study the next part of this topic. First point, advantages of potentiometer over voltmeter. There are three advantages. One, potentiometer is more sensitive than the voltmeter. This is first advantage of potentiometer. Second, potentiometer can be used to measure potential difference as well as EMF of given cells, but voltmeter can only use to measure potential difference because voltmeter drives some current through it. This is second advantages of potentiometer over voltmeter. And third, potentiometer is accurate than voltmeter because potentiometer can measure very small potential difference near about 10 raised to minus 6 volt. Due to that reason, potentiometer have some advantages over voltmeter. Then, next we study the disadvantages of potentiometer over voltmeter. There are some disadvantages. First, potentiometer is not a portable device. That means we can't displace that device from one place to another place easily. So this is disadvantages of potentiometer. And second, potentiometer is not a direct reading instrument. We can't measure potential difference as well as EMF of given cell directly with the help of potentiometer. These are two disadvantages of potentiometer. Then next point is that galvanometer. This is another meter similar to potentiometer known as a galvanometer. It is a device used to measure a very small amount of electric current flowing through electrical circuit. That galvanometer consists of a coil like this. This coil is freely suspended or pivoted between two concave shaped pole pieces of horseshoe type permanent magnet like this. Due to these two pole pieces, a radial uniform magnetic field is developed across this coil. This coil is freely suspended to the rigid support like this. When current flows through the coil, suppose I be the current flowing through the coil, the field produced across the coil by means of these two poles exert some force on that coil, and a torque will exert on that coil due to that field. Due to that torque, coil gets deflected. Suppose theta be the deflection of the coil and I be the current flowing through the coil. Then it is observed that deflection of the coil is directly proportional to the current flowing through the coil. That is, theta is directly proportional to I, or I is directly proportional to theta. Means deflection of the coil in galvanometer is directly proportional to the current flowing through the coil of galvanometer. This galvanometer coil having moderate resistance. Due to that, this galvanometer can detect very small amount of current, near about 1 milliampere. That means this galvanometer can detect very small amount of current, that is weak current, near about 1 milliampere. In order to measure current greater than 1 milliampere, we have to convert that galvanometer into an emitter as well as voltmeter to measure large amount of potential difference across any circuit element. That means this galvanometer to be used in two ways. One, as an emitter, and second as an voltmeter. First, we will study how will you convert a galvanometer into an emitter. For that, how will you convert galvanometer into an emitter to measure or to detect large amount of current greater than 1 milliampere. To convert MCG, moving coil galvanometer, or simply galvanometer, into an emitter for the measurement of large current. Suppose this is coil of galvanometer G. Coil of galvanometer having resistance G. A very low resistance connected in parallel with coil of galvanometer. This is S, called as shunt resistance. Here, this is resistance R, and this is I with the current to be measured with the help of emitter, like this. This is circuit diagram to convert moving coil galvanometer into an emitter for the measurement of current. Here I with the current to be measured, R is the resistance, G with the resistance of coil of galvanometer. This total current flowing through the circuit at this point, you see junction point within that circuit. At this point current divides. Current Ig flows through G and current Is flows through S. In order to convert that moving coil galvanometer into an emitter by connecting very low resistance in parallel with coil of galvanometer, such resistance is called as shunt resistance. Why this shunt is connected in parallel with the coil of galvanometer? For that, we consider the function of that shunt. First function of that shunt to be connected across G in order to convert MCG into an emitter. This is first function. This shunt can decrease effective resistance of that circuit. This shunt can decrease effective resistance of that circuit because this shunt S is connected in parallel with coil of galvanometer. Second, this shunt increases the range of that instrument. Also, this shunt increases the capacity of that instrument to measure large amount of current. Also, this shunt is useful for protection of that instrument from damage. Coil of MCG is moderate to be damaged after passing large amount of current to protect that damage from. So we have to connect that shunt across that coil of MCG in parallel. This is the function of shunt in that circuit. Then how to calculate the value of shunt? By considering this circuit diagram. Here I give the total current flowing through the circuit to be measured. At this point current divides. Ig flows around G, Is flows around S. These two G and S are connected parallel to each other. Therefore, potential across G exactly equal to potential across S. From this figure, we write some equations like this. I equal to Ig plus Is, or Ig equal to I minus Is, and Is equal to I minus Ig. Also, the potential across G and S must be same, that is Vg is equal to Vs. Potential across G exactly equal to potential across S because G and S are parallel to each other. Therefore, Ig into G is equal to Is into S. Then substitute the value of Is. Is equal to I minus Ig. Therefore, Ig into G equal to Is equal to I minus Ig into S. To calculate the value of S, Ig divided by I minus Ig into G. This term is dividing this LHS. Ig divided by I minus Ig into G equal to S. This is the formula for determination of value of shunt resistance. S is equal to Ig divided by I minus Ig into G. This amount of shunt is to be connected across G in parallel with G in order to convert MCG into an emitter. Also, from this relation we can write something here. This current I, total current flowing through the circuit, divides at this point Ig, Is. Here total current I can be written like this. I is equal to N times Ig. Total current flowing through circuit I is equal to N times Ig. Substitute I is equal to N times Ig in this relation. Suppose this is equation number 1. Therefore S equal to Ig divided by, substitute value of I equal to N times Ig minus Ig into G. Here we take common Ig. S equal to Ig divided by Ig into bracket N minus 1 into G. Here Ig gets cancelled. Therefore S equal to G divided by N minus 1. This is another formula for determination of S in terms of factor N. That means This amount of shunt is to be connected across G to increase the range of that instrument n times. Then also we have some equation. Here potential across G equal to potential across S, that is Vg equal to Vs. Ig into G, according to Ohm's law, Ig into G equal to Is into S. Substitute the value of Ig. It is I minus Is. Ig equal to I minus Is into G equal to Is into S. Multiply by G, that is I into G minus Is into G equal to Is into S. This term towards right, that is Ig, this term going on towards right, that is Is into G plus Is into S. Take the common Is. Ig equal to Is into bracket G plus S. Then rearrange the equation, you will get G divided by G plus S equal to Is divided by I. Means Is divided by I is equal to G upon G plus S. This formula gives us fraction of current, fraction of total current flowing through shunt given by the formula Is divided by I is equal to G divided by G plus S. This is about how to convert MCG into an emitter for the measurement of large current. Similarly, we have to convert MCG into an voltmeter for measurement of large potential difference across any circuit element within an electric circuit. Then we will study how to convert MCG into an voltmeter. Suppose this is a coil of MCG having resistance G. Connect high resistance in series with coil of MCG like this. This is resistance R and this is voltage V. This is voltage V to be measured with the help of voltmeter. Suppose this is Ig with the current flowing through coil of galvanometer. This is high resistance connected in series with coil of galvanometer. This is G with the resistance of coil of galvanometer. In order to convert this galvanometer into an voltmeter, we have to connect high resistance X in series with coil of galvanometer. Here V with the potential difference or voltage to be measured with the help of that galvanometer. This is construction of conversion of moving coil galvanometer into an voltmeter for the measurement of current. So for the measurement of voltage. That means we have to connect high resistance in series with coil of galvanometer to convert MCG into an voltmeter. Then we will see the function of that high resistance. Why we connect that high resistance in series with coil of galvanometer? First function, in order to increase the voltage capacity of instrument, we have to connect high resistance in series with coil of galvanometer. Also, in order to protect that instrument from damage, we have to connect that high resistance in series with coil of galvanometer. And also to increase the voltage capacity, means range of voltmeter. For that reason, we have to connect that high resistance in series with coil of galvanometer. Then, how will you find out the value of high resistance? For that, consider this circuit. From this circuit, we can write something. Here V with the potential difference to be measured, Ig with the current flowing through coil of galvanometer as well as high resistance X. Then from figure we can write some equation. V is equal to total potential equal to potential across G, that is Vg, plus potential across high resistance X, that is Vx. Using Ohm's law, V is equal to IR, current flowing through G, Ig into resistance of G plus current through high resistance Ig into resistance X. Take the common term outside, Ig into bracket G plus X. Then divide this Ig by V, that is V divided by Ig equal to G plus X. Last, that is X equal to V upon Ig minus G. This is the formula for determination of high resistance X connected in series with coil of MCG in order to convert MCG into an voltmeter for the measurement of high potential difference. Also, we have some relation. V is equal to N times Vg. V be the total potential to be measured, Vg be the potential across G. We can write some equation. V is equal to N times Vg. Substitute this value in this equation number 1, V equal to N times Vg. Equation 1 becomes X equal to V equal to N times Vg divided by Ig minus G. Using Ohm's law, N into V is equal to Ig into G divided by Ig minus G. This term Ig is common, gets cancelled. Therefore, X equal to G into bracket, common term G into bracket, N minus 1. This is another formula of X in terms of N. That means we have to increase the range of that instrument N times. For that, we have to connect this amount of high resistance in series with coil of galvanometer. Also, we know that ideal emitter has zero resistance. Similarly, ideal voltmeter has infinite resistance. This point is most important because such type of question to be asked in CET exam as well as JEE or MST CET exam MCQ study. That is, for ideal emitter, resistance is always equal to 0. For ideal voltmeter, resistance is always infinite. This is about use of galvanometer as an emitter as well as voltmeter. Question in board exam to be asked like this: how will you convert moving coil galvanometer into an emitter as well as voltmeter? Then next point is that comparison of emitter and voltmeter. We have to compare these two instruments, two meters, one emitter and second voltmeter. First point regarding the comparison of emitter and voltmeter. Emitter measures current, electric current in an electric circuit. Similarly, voltmeter measures potential difference across any circuit element in an electrical circuit. Second point, emitter always connected in series within that circuit, while voltmeter always connected in parallel across that circuit element. Third, MCG with low resistance called as shunt is called as and emitter. That means MCG with low resistance called as emitter, while MCG with high resistance is called as voltmeter. Next, the resistance of emitter is equal to Ra is equal to G into S divided by G plus S. That means Ra is equal to G divided by, and Ra resistance of emitter equal to G into S divided by G plus S, because G resistance of galvanometer and shunt to be connected parallel to each other, then effective resistance of that combination means resistance of emitter Ra equal to Gs divided by G plus S, that is Ra equal to G divided by, and similarly resistance of voltmeter equal to G plus X equal to G into N, because MCG and high resistance are always connected in series. Therefore resistance of voltmeter equal to G plus X equal to Gn. This is because X equal to G divided by N minus 1, and in this case X equal to G to bracket N minus 1. These are some points of comparison of two meters known as emitter and voltmeter. Thank you.